Hello, and welcome to this flipped classroom video. Today we're going to talk about right triangles and trigonometry in our Unit 1 here. And today's target is the law of sines. Previously, with trigonometry, sine, cosine, and tangent, it's all been with right triangles. And every single time I want to solve for a missing side or missing angle, I need to have a right triangle. It's one of the requirements in order to use trigonometry. So the question that we get is, well, what happens when I want to find a missing side or a missing angle in a triangle that's not a right triangle? And one of the methods is to use what's what we call the law of sines. So right here we have triangle ABC, and triangle ABC is going to have side lengths of A, B, and C also. We use uppercase A, B, and C to represent the angles, and then a lowercase a, B, and C to represent the sides. Now the order is important as far as which side is A, which one's B, and which one's C. And we'll show that to you right now. So we'll start with side A, and side A is going to be located opposite angle A. So angle A is right here. So if I want to go opposite, I'm going to go across the triangle this way, and this would be my opposite side. Therefore, that's going to be my side length that I'm going to call A. And then the same goes for the other two angles. Again, angle B is located right here. So then side B is going to need to be located opposite angle B, and that's this side, AC, over here. And then the same goes for angle C. Angle C located here, opposite angle C would be AB. So this is going to be my third side, C. So now that we've labeled our sides, A, B, and C, the law of sines is this ratio, sine of A, side of angle A, over side length A, equals side of B over B, equals sine of angle C over side length C. And this is a proportion, so I can solve this. And I only need two of these three to actually solve. So like I said, this is going to be for a non-right triangle. If this were a right triangle, we could use just regular trigonometry to solve this, but it's not a right triangle, so I'm not going to be able to solve this. So the first thing I should probably do here is, given angle A and angle C, is I should figure out what angle B is, because I know that all triangles add up to 180 degrees. So let's take 22 and 70, add them together, that gives you 92 degrees. Subtract 92 from 180, which gives me 88 degrees for the measure of angle B. So I have two missing sides for this example, A and C, and I want to find the measures of each of them. So just a reminder, let's go ahead and put our law of sines up here. And remember, it's the sine of angle A over side length A equals the sine of angle B over the side length B equals the sine of angle C over the side length C. And then the next step is, let's plug in what we know into this proportion. So sine of A, well, we know angle A is 70 degrees, so I'll put 70 in here, over side length A, which I don't know, we'll just leave that as A, is equal to the sine of B, which we just found out is 88 degrees, over side length B, which is 16, because the 16 is opposite angle B, and then sine of angle C, which I know is 70 degrees, over side length C, which again I don't know. So now my portion starts to take place. And I want to solve for both A and C. In order to do this, I'm going to use my middle proportion here. And that's going to be what I'm going to use to figure out what side length A and what side length C is. So first, we'll take the first two ratios that I have and set them equal to each other. So we are going to cross multiply. Because when I have a proportion, it's one way to solve it, is I can take the sine of 70, multiply that times 16, and then take A and multiply that times sine of 88. Now we don't want to multiply anything out with our sines as far as getting decimals right now. We're going to leave everything as, sine of 88 or sine of 70. So after cross multiplying, I get A times the sine of 88, which is going to be just A times sine of 88. And that's equal to 16 times sine of 70. So remember, the end goal is to get A by itself. So I need to get rid of this sine of 88. So I'm going to divide the left side by sine of 88. And whatever I do to one side, I need to do to the other side as well. So divide by sine of 88. And the left-hand side, the sine of the 88 is going to cancel out, and I'm left with a, which is what I'm trying to get in the first place. And then we'll go ahead and get our calculator. Now I'm going to type into my calculator what I have on the right-hand side, which is the 16 times sine of 70 all over sine of 88. And I'm going to use parentheses to make sure that I don't make any mistakes. So I'll do parentheses, and I'll do 16 times sine of 70. Oops. Now notice that when I do my sine, I get a parentheses, and I'm going to need to put another parentheses to close this. So you see I just have two parentheses at the end here, so that's the 16 times sine of 70. I'm going to divide that by the sine of 88. So sine of 88 close that parentheses, and then press enter. And that should get 15.04. We'll go 2 decimal places, so 15.04 will be the length of side A. So A is 15.04, and now it's time to go back and find out what C is. So similar setup, only I'm going to use, I'm still going to use sine of 88 over 16, but I'm going to use sine of 70 over C to find out what measure of angle C is. And I'm sorry, this should be 22, not 70 up here. So let's go ahead and change this to 22 instead of 70. And just like before, we're going to cross multiply. So sine of 88 times C. It's going to give me C times sine of 88 equal to 16 times sine of 22, which we'll just leave as 16 times sine of 22. And we want to get C by itself, so I'm going to divide by sine of 88 on both sides. Sine of 88 is going to cancel out on the left. Now I'm left with just C, and then again I'm going to put in my calculator 16 times sine of 22 divided by the sine of 88. Make sure we're careful and use parentheses with that. And I'm going to get about 5.997, which we'll go ahead and round up to 6. So C will equal approximately 6 for this case. And I have my 3 sides. Now one way we can double check our answer is by going back and plugging my 3 sides into into the formula and making sure the ratios work. So in my calculator I'll just say sine of 70 divided by 15.04, and that's going to give me 0.0624795626. We'll try sine of 88 divided by 16, and as you see it's not exact, but it's really close. And then last but not least, we can check sine of 22 divided by 6. And again, it's really close. Not exact, but it's really close. So you see all 3 ratios here, and they're all close, which means I have my 3 sides. Now we can also use the law of sines to find missing angles. So we found missing sides with example 1. So example 2, we're going to find our missing angles. So again, we'll go ahead and set this up. It's going to be, remember, it's sine of A over side A, which is the opposite side. So we'll say sine of angle A, which is 61 in this case, so I'll just go ahead and put 61 in there, over side A, that's the opposite side, which would be 14 in this case, is equal to the measure of angle B, so sine of angle B, which I don't know, over the opposite side, which is AC, which I also don't know, so we'll call that lowercase b, and that's going to be equal to my third part of the proportion, which is the measure of angle C, sine of angle C, which again I don't know, over the side length that's opposite that, which is going to be 8. Now in this particular case, if you notice right here in the middle of my proportion, I have sine of B over B, and what I'm looking for is the measure of angle C. So I don't really need this middle part of the proportion. So I can actually just get rid of it. It's not going to help me out in this particular case. And the proportion that I'm going to use is going to be sine of 61 over 14 equals sine of c over 8. And we're going to cross multiply like we've done previously. So I'll take sine of 61 times 8. And that's going to be equal to 14 times the sine of c. And we want to get the sine of c by itself, so let's go ahead and get rid of the 14. So divide both sides by 14. 14s will cancel. And I'm going to end up with, so 8 times the sine of 61. Make sure we close our parentheses. If we don't, we're going to get the wrong answer. Divided by 14. And I'm going to get 0.49978268898. So this is my approximate answer. So we'll call it, we'll do, I don't know, let's do 5 decimal places, 0.49978. And that's going to be equal to the sine of c. So just like we did in our inverse trig target, we have sine of c. We need to undo sine. So in order to undo sine, I'm going to need to take the inverse sine of the right, which this is going to cancel out and give me c, which is what I'm looking for. But whatever I do to one side, I need to do the other side. So inverse sine of 0.49978. So second sine 0.49978, and that's going to give me 21.985. We'll say 29.99 approximately. Remember, this is going to be in degrees. So 28.99 degrees, and this is going to be my answer. Now the third example has you solve the triangle, so find the missing sides and find the missing angles using law of sines. Go ahead and do this one on your own. I'll put the answer up here in a second, and so go ahead and pause the video right now. Do the problem on your own, and then when you unpause it, I'll tell you what the answer is. So the three things I'm looking for are the measure of angle C, B, and C. So we see that C is 41 degrees, B is going to be 19.03, and C will be 14.01. If you have questions, make sure you write them on the side and ask them tomorrow when I see you.